Hello. The purpose of this lab is to observe the motion of an object that is moving on the same speed without changing direction. For this purpose, I use the car moving at a constant speed. From the car experiences, I applied the momentum principle of Newton's second law to explain what's happening on the video. First, the observations made on the car with the first observations on the VPython made with the assumption that the air resistance was ignored. Also, terminal velocity and terminal position were found by these models. This is my video clip of the car moving at a constant speed. The first frame sets the origin of the system, starting at the center of the mass. For this purpose, I used a blue sticker, as you can see here, just to define this center of mass. The clip starts with the car moving from right to left. The negative side of the x-axis points to the left at the direction of the car, and the positive side of the y-axis points upwards. The measurements cover the length of the car, which is originally 4.19 meters. These are my decisions for the length scale and the coordinate system. Let's see now the computational model made on VPython and look through the settings I did. First of all, I set the initial position of the car and the initial velocity of the car. To do this, I used the measurements I took from tracker just to find car's initial velocity from the well-known equation. I set Fnet equals to 0, which is something I will talk later in the video. Also, I wrote equations of Newton's second law about the velocity and the prediction of the position of the car. Not to forget, the while loop terminates when time reaches is 2.64. Let's run now the program and see what happens, of course. This seems very good. Okay, now it's time to compare the observed data and predicted data. With blue spots represent the experiment and the red line represent our model. As it is expected, the negative position increases as time increases. This is logical as the car moves from right to left. We can also observe that there is a little deviation in this particular area, and I think this is happening because the car didn't have the same velocity all the time. What we did in this lab, we took the measurements from the experiment and we set the initial velocity and position of the car. These quantities contain all the history of the car in order to predict the translational motion feature of the car. Remember that in Newton's second law we know the system mass and we assume that total interactions are 0. On the car exert 4 forces: gravitational force, force from the engine, friction, and of course reaction from the road. So the Fnet of this equals 0. Finally, what would happen if we flip the axis? Let's take a look. As you can see, all measurements are changed. We run again the program in VPython and the results are exactly the same. The only difference is the orientation of the straight line due to the positive x-axis. So, the conclusion is that the computer model and the observation data match well each other, and the fundamental principles are strongly connected to the motion understanding. Thank you very much.